Hi guys, my name is Andrew. I'm an industrial design student at OCAD, and I'm here today at Walter Klassen FX, which is a Toronto-based company that makes film props and Steadicam equipment. Today we're going to be discussing polyurethane resins and their use in the film industry. So if you look to my left here, you'll see these blades. These are from a scene that wasn't used in the Adam Sandler movie Pixels. I'm going to use them to demonstrate the point that the film industry has some very peculiar requirements and material applications. So, for example, this blade that I'm holding is what's referred to as a hero blade, and it's made out of more expensive materials. This is aluminum that's been anodized to look gold, and this is typically used for close-up shots where it has to kind of shine and look pretty. And this one is made from 3D printed epoxy resin that's cured with a UV light. It's a little bit less expensive. And then this final one here is made from a polyurethane resin called Task 13. And this one would be used for like fight scenes, any sort of scene where somebody could get hurt. So we're actually going to be using Task 13 to create a replica of this knife that we got at Canadian Tire. We'll walk you through all the steps that are required to do that. So in the first video segment, we are going to be making carbon fiber inserts so that it's not quite as flimsy as that, holds its shape a little bit better. Then in the second video, we will make a 2-part silicone mold. And in the third video, we will actually fill this mold with Task 13 and another polyurethane resin called Flex Foam. So, sit back, relax, and enjoy.
The process begins by measuring out and cutting the individual carbon sheets in order to make a laminate. The size of the laminate is dependent on the size of the production run. In this case, several replicas are being made. Once the sheets are cut, a sheet of poly is glued to a block of MDF large enough to cover the entire laminate. The plastic sheet helps keep the epoxy resin from leaking out and making a mess. The next step is to measure out the amount of epoxy resin needed to bind the layers of the laminate together. This epoxy is mixed together at a ratio of 38 parts hardener to 100 parts epoxy, in enough quantity to cover the footprint of the layup several times over. However, there are a number of more accurate ways to determine how much epoxy is required, including by weight and by volume in relation to the amount of fiber, depending on the performance requirements of the object. In this case, the blade simply has to be strong enough to withstand repeated blows without suffering any plastic deformation, and at the same time, be rigid enough that it doesn't undergo elastic deformation while it's being waved around on camera. Carbon fiber is better suited to perform this task than acrylic of the same thickness, which is too brittle, or polycarbonate of the same thickness, which is not rigid enough to be convincing on camera. Furthermore, carbon fiber is lighter than either of these materials. Keeping props lightweight is often a key constraint. A base layer of epoxy is brushed onto the plastic-lined MDF before the first layer of the laminate is laid down. Each layer of the layup has both sides coated in epoxy. Rollering the sheets helps to remove excess resin, which in turn reduces the weight of the laminate. For this particular application, 6 layers is the ideal amount. The resulting laminate will be thin enough to fit within the narrow width of the blade, but thick enough that it can be sanded into shape without compromising the integrity of the insert. Once the laminate has all its layers, the the plastic sheet is wrapped around the laminate to create a bag that will catch the excess resin. From here, the laminate is sandwiched between another block of MDF before being placed in a press. Placing the piece under high compression helps expel any excess resin while ensuring a strong bond between the layers. The layup is left to cure overnight. Now that the laminate is complete, all that's left to do is to shape the inserts.